In this lesson, you will learn how to use the greatest common factor to help you rewrite algebraic expressions. Now recall that factors are terms that are multiplied together to form a product, and the greatest common factor is the factor that can be pulled out of an expression to simplify it. So for example, let's talk about the expression 8x squared y plus 12x. And we want to rewrite this expression in a different way. To do that, we need to identify the greatest common factor of both terms. So you need to find the factors for 8x squared y and 12x. These are our two terms. So the factors of 8x squared y are the numbers, I'm just going to put an equal sign, but that's not equal. But the factors are 1, 2, 4, 8, and then you have x squared being multiplied, and you have y. Down here, you've got 12x. The factors are 1, 2, 3, 4, 6, and 12. And lastly, the factor of x. Now identify the greatest common factors. When you look at these lists, you see the number 4 is listed in both spots. So in terms of the coefficients, we're going to be pulling out a 4. And then you have 12x, which has an x, and you have x squared up here. And x squared can be broken down into x times x. So we can pull out a factor of x. So when you factor this expression above by pulling out the greatest common factor, which is 4x, what are you left with? You're going to be left with 2xy for the first term plus 3. Now, if you want to check this and see if it's right, you can use the distributive property to multiply the term 4x by each of the terms inside the parentheses and see if you get back to the original expression. Let's try a problem together. So here we have the expression 64x squared minus 25, and we want to factor this completely. If the first and second term of a binomial are perfect squares, and it is written in the form where you have a squared minus b squared, then this binomial represents a difference of squares. Now I'm bringing this up because when I look at the binomial we have here, I can see that 64 and 25 are both perfect squares. Now we look at this form, right? A squared minus b squared. You can find the value of a by taking the square root of the first term, which is altogether 64x squared. This is the first term. And then you can find the value of b by taking the square root of the second term, and the second term in this case is 25. So you go ahead and you take the square root. When you take the square root of 64x squared, right, the square root of 64 is 8, and the square root of x squared is x. So the square root of this entire term is 8x. Now we're going to do the same thing here. Take the square root of 25, and you get 5. In factored form, right, when we're talking about the difference of squares and we want to talk about the factored form of that, you have a squared minus b squared. In factored form, looks like a plus b times a minus b. So how would you express 64x squared minus 25 in factored form? You have your a terms, right? We already know what a is, and we already know what b is. So what we're going to do is just use this expression here to write our factored form. So a is 8x. So let's start with the first. You want a plus b. So you're going to have 8x plus 5. And in the second parentheses, you want to have a minus b. So you'll have 8x minus 5. And this is how we take the difference of squares, general formula here, not really formula, but form, and we can factor the binomial that we were given. And the reason we were able to do that was because we noticed that 64x squared and 25 are both perfect squares. Now let's try a problem that has more than two terms. Here we have an expression that has 4 terms, and we want to factor this. Now, all 4 terms of this polynomial do not have a common factor. But what you can do is you can group together terms that do have common factors and just throw in some parentheses to group them. So I'm going to group the first 2 terms because I see that both terms have a y variable, and I'm going to group the last 2 terms because I know that 3 and 12 are, multiples, right? So 3 times 4 is 12. So I know that I can factor these as well. So let's begin with the first parentheses. We need to find the greatest common factor of y x, or xy and 4y. Well, that will just be y. So if you're talking about xy and 4y, right, the greatest common factor becomes y. So let's factor out a y of the first parentheses. What you're left with is x plus 4 inside the parentheses. Now what we can do is do the same thing over here with 3x and 12. So you have 3x, and the factors here are 1, 3, and x, and then you've got 12, and the factors here are 1, 3, 4, 6, actually 2. I didn't do this in order, but so here are all the factors, and lastly 12. So you see the greatest shared factor or common factor is 3, which means we're going to factor a 3 out of the second parentheses. What you're left with inside is x plus 4. Again, you can check this by using the distributive property to multiply back and see if you get your original expression. And now I just want to draw your attention to something. You see that when we factored, we're left with the same terms inside these parentheses. So we can take this one step further. If you notice, you have y times a term plus 3 times a term. Let's just say I wrote this as yb, right? And in this case, we're going to let b equal x plus 4, right? So y times b plus 3 times b. Well, what could I do here? I could pull out the b, right? Y plus 3. And in this case, b equals what? Well, b equals x plus 4. So I'm going to substitute that. X plus 4 for b times y plus 3. So what I've done is I've taken this expression that had two binomials being added together, and then I turned it into a multiplication of two binomials instead. And this is the fully factored form of the expression we were given above. So although at face value it didn't seem like we could factor this beyond the two groups that we had done, but in fact we could, right? And that was because we saw that we ended up with the same binomial being multiplied by coefficients once we did the first step of factoring. In this lesson, you've learned how to rewrite expressions using the GCF. Now go out there and solve some problems.